Hello friends, welcome to SSP Math. Today we are going to start most important topic in linear algebra, that is basis and dimension of vector space. So first, what is basis of vector space? How we define basis? A sequence of vectors v1, v2 up to so on vn is a basis of v. Means we can say that v1, v2 up to so on vn is a basis of vector space v if v1, v2 up to so on vn spans v. That is, if we write, suppose v be the any vector of v, and if we write that vector in as a linear combination of v1, v2 up to so on vn, that is c1, v1 plus c2, v2 plus so on plus cn, vn, where c1, c2, cn belongs to R. If this condition is satisfied and v1, v2 up to so on vn are linearly independent, then we can say that v1, v2 up to so on vn is a basis of vector space v. So for basis of vector space v, first we have to check spanning and then linearly independent. Okay, then using basis, how we find dimension of vector space? So dimension is most important topic again. So the dimension of a vector space v is the number of vectors of a basis of v. For example, the vector space R3 has 1 0 0 0 1 0 0 0 1 as a basis, because this 1 0 0 0 1 0 0 0 1, these are the linearly independent vector. So dimension of R3 is 1 2 3, means that is the dimension of a vector space v is the number of vectors in a basis of v. So in a basis of R3, number of vectors are 1 2 3. So dimension of R3 is equal to 3. Now first we will take some problems on basis. So first problem is, show that the set 1 1 1 minus 1 is a basis of R2. So we have to show that this set is a basis of R2. Simply, if we take, suppose v1 is first vector here 1 1 and v2 is second vector, that is 1 minus 1, then we have to check that this v1 and v2 spans R2 and v1 and v2 are linearly independent or not. So how we check spanning set? First, if we take, suppose one vector, that is xy belongs to R2, okay, or xy belongs to R2, then we have to check that this, if we write this xy is equal to c1 v1 plus c2 v2, then we can say that given set is a spanning set. Okay, so this is equal to v1 put here, that is c1 into 1 1 and plus c2 into 1 minus 1. So if we multiply this c1 c2 inside here, c1 into 1 is c1 plus c2 into 1 is c2, that is c1 plus c2, and by equality of matrices this is equal to x, and second equation is c1 minus c2 is equal to y. Now if we write this system in matrix form, then we will get 1 1 1 minus 1 into c1 c2 is equal to xy. Okay, and from this, if we write augmented matrix AB, that augmented matrix AB is here. AB means this is say A, this is X matrix and this is B matrix. Okay, so AB matrix is joining of A and B, that is 1 1 X and 1 minus 1 Y. And if we reduce this matrix to canonical form, then we will get, we have to use here operation R2 minus R1. So if you use R2 minus R1, then we will get 1 1 X, 1 minus 1 is 0, minus 1 minus 1 minus 2, and Y minus X. Now observe this matrix carefully. Here rank of A equal to 2, rank of AB is also 2. So rank of A equal to rank of AB, and if rank of A equal to rank of AB, means this has some solution, and therefore given set is a spanning set. Given set is a spanning set, means this system has some solution. If it has some solution, then we can write xy as a linear combination of v1 and v2. Okay, and therefore given set is a spanning set. Now we have to check, second condition is linearly independent. We have to check v1 and v2 are linearly independent or not. So how we check? For linearly independent, we have to consider c1 v1 plus c2 v2 is equal to 0. And I think from this equation here, c1 v1 plus c2 v2 is equal to xy. So if we put xy equal to 0 0 in spanning set, then we will get c1 v1 plus c2 v2 equal to 0. if we put here v1 v2 and after simplification we get same matrix here. Okay, so in this matrix if we put x equal to 0, y equal to 0, then we will get 1 1 0 minus 2 0 0. Okay, so using this we can write system, that is c1 plus c2 equal to 0 and minus 2c2 equal to 0. So using this c2 equal to 0, if c2 equal to 0 if we put here, then we get c1 is also 0. Okay, so c1 equal to 0, c2 equal to 0, and therefore v1 and v2 are linearly independent, and also this given set is a spanning set, and therefore we can say that the set 1 minus 1 1 and 1 minus 1 is a basis of R2, is a basis of R2. So same problem है, verify that the following sets are basis. These are the, for practice you solve these questions. So we have to verify that these sets are basis or not. First one is 1 1 minus 1 1, same as last problem for R2. Then for R3 1 2 3 2 4 1 3 0 0, and same take third problem, that is 1 1 4 2 1 3 and 0 1 6. So these are the some problems related on basis, means how to check given vectors forms a basis or not, or given set is a basis or not. Now we will take some problems on basis and dimension, how to find basis from given set. Suppose W is equal to a plus b such that AB belongs to R. Find basis and dimension of W. So how to find basis and dimension of W? Now the vector of W given here a plus b. Okay, so this vector can be written as a into 1 0 1, means if you multiply a inside this, plus b into 0 1 1, means if you multiply a and b inside and if you take addition, then we will get this, that is a, then a into 0, that is 0 plus b and a plus b. Okay, so what is this here? If you take, suppose v1 is equal to 1 0 1 and v2 is equal to 0 1 1, so we can write a plus b is equal to a v1 plus b v2, means therefore the vector of W, which vector, this vector of W can be expressed as a linear combination of, v1 and v2. Okay, means so the vector of W is a spanning set, and therefore W is spanning set. Okay, now we have to check this v1 and v2 are linearly independent or not. So how we check that? Two vectors say there exist two scalars c1 and c2 such that c1 v1 plus c2 v2 equal to 0. So c1 into 1 0 0 plus c2 into 0 1 1 equal to 0 0 0. So using this we can write here c1 plus 0 c2 equal to 0, means इससे c1 directly 0 मिला, then c2 equal to direct 0 मिल रहा है हमें, and c1 yes c2 equal to 0, c1 equal to 0, and therefore v1 and v2 are linearly independent. Okay, so v1 and v2 are linearly independent, and therefore what is the basis of given set? That is v1 1 0 1 and 0 1 1 is a basis of W. Now if 1 0 1 and 0 1 1 is a basis of W, then what is its dimension? Dimension is the number of elements in, number of vectors in basis, that vectors are 1 and 2, so dimension of W is equal to 2. Now next problem is find basis and dimension for span 1 2 3 minus 1 minus 2 minus 3 and 0 1 1. So we have to given here a row vector. Suppose first vector is v1, that is 1 2 3, second vector is v2 minus 1 minus 2 minus 3, and third vector is v3 given as 0 1 1. Okay, So we have to find basis of this. Basis means we have to find linearly independent vectors from this. Okay. So if we write matrix A from these vectors, these are the row vectors. So write rows of matrix as a V1 is first row, that is say 1, 2, 3, then -1, -2, -3 and 0, 1, 1, and reduce this matrix to canonical form, because we have to find linearly independent vectors. So for that we have to use R2 plus R1 operation. So if we use R2 plus R1, then we will get 1, 2, 3, -1 plus 1 0, -2 plus 2 0, -3 plus 3 0, and last row as it is, that is 0, 1, 1. Now if we interchange here second and third row using operation R2 3, then this matrix becomes 1, 2, 3, 0, 1, 1 and 0, 0, 1. So what are the linearly independent vectors here? This and this. So what is the basis of this? That is, therefore basis of given set is equal to first vector is 1, 2, 3 and second vector is 0, 1, 1, and number of vectors in basis are 2, so its dimension is equal to 2. Dimension equal to 2 here. The next problem is find basis and dimension for row space of the matrix A equal to 2, 0, 3, 4, 0, 1, 1, -1, 3, 1, 0, 2, 1, 0, -4, -1. So how we solve such type of problems? Here we have to find basis and dimension for row space of this matrix. So in solution, first we have to write this given matrix as it is and simply reduce this matrix to canonical form. So we have to find only linearly independent vectors from this, that is the basis of this matrix, okay, or basis of row space of this matrix. So for that, first we have to use operation R14, interchange first and fourth row. So if we use R14 operation here, then 1, 0, -4, -1, second row as it is 0, 1, 1, -1, third row also as it is 3, 1, 0, 2, and fourth row write 2, 0, 3, 4. Okay, now we have to make, or we have to convert this matrix to canonical form using only row operations. So we want here 0, here 0, so use operation R3 minus 3 times R1 and R4 minus 2 times R1. So if we use this operation, then this matrix becomes 1, 0, -4, -1, 0, 1, 1, -1, 3 minus 3 0, 1 minus 3 into 0 is 0, so 0 minus minus plus 3 into 4 is 12, then 2 plus 3 is 5, 2 plus 3 is 5 here, then 2 minus 2 is 0, here also 0, 3 minus minus plus 3 minus minus plus 8, that is 11, okay, and then 4 minus minus plus 2, 6, 4 plus 2 is 6. Next operation is we want here 0, so use operation R3 minus R2. So if we use R3 minus R2 operation, then we will get 1, 0, -4, -1, 0, 1, 1, -1, 0, 0, 12 minus 1 is 11, 5 minus minus plus 1 is 6, and last row is as it is 0, 0, 11, 6. So here we get two rows same here, so use last operation, cancel one row because these rows are same. So if we use operation here R4 minus R3, then we will get 1, 0, -4, -1, 0, 1, 1, -1, 0, 0, 11, 6, and last row is 0, 0, 0, 0. Okay, so what are the linearly independent vector? That is R1, R2 and R3, and therefore we can write here basis is equal to first vector is 1, 0, -4, -1, second vector is 0, 1, 1, -1, and third vector is 0, 0, 11, 6. So this is the basis of row space of this vector. What is dimension here? Dimension is the number of vectors in basis, that is 1 2 3, so dimension is equal to 3. So next problem you solve at home. Problem is find the basis and dimension for column space. Column space of the matrix 1 1 0 2 3 minus 2 minus 1 minus 4 6. So you have to find basis and dimension of column space of this matrix. So suppose matrix A is equal to given matrix. So first write down transpose of this matrix. How we write transpose here? 1 2 minus 1, then 1 3 minus 4, and 0 minus 2 6. Okay, and now remaining part is same. Reduce this matrix to canonical form and write number of linearly independent vectors, that is the basis of given matrix, and count the number of linearly independent vector, that is also dimension of that matrix. Okay, thank you.